Hello, and welcome back for a new technical overview and demo today. I'm Fabien Senglier with SoftwareAG Government Solutions here in the US. This time, I'll show you how you can deploy a realistic, prod-ready SoftwareAG Web Method API Management platform to Kubernetes in a matter of minutes. I'll walk you through some of our ready-to-use assets to make this possible: containers, Helm Charts, and a sample deployment guide that you can follow on your own time. But first, for those new to SoftwareAG and our leading API management platform, let's make a quick detour on the basics. In short, SoftwareAG API Management is a comprehensive solution for all your API needs. It includes three main components with their own respective strengths and features. First, we have the API Gateway. This component is all about protecting, transforming, monitoring all your runtime API traffic. Because it proxies all your API runtime traffic, it's designed for high performance and high scalability. And that's one of the aspects we'll take a look at during this demo. Then we have the developer portal. As its name suggests, this component is there to promote all your APIs to the developers at large. Since, after all, app developers are the ones who will want to use these APIs in their own apps. In Developer Portal, these developers will find things like API documentation, schemas, versions, onboarding abilities, and even a tryout API ability as well, so they can check firsthand how the API works. And finally, the API design and integration layer, where you can actually implement the APIs from scratch, connect them with any backends you wish, like a database, a cloud service, a SaaS application, and even a mainframe application. And then you can also run these APIs directly on our high-performance runtime. Now, of course, there's much more that could be said on each of these components. But in the interest of time and to stay focused on the topic of this demo, let's just move forward and review our goal here, which is deploy the API management solution in Kubernetes in minutes. So here is a high-level diagram of what we're going to deploy here today. First, we have one deployment for an API Gateway scalable cluster. Second, another deployment for Developer Portal cluster. And because each of those components require a data store in the form of Elasticsearch, we'll have a third deployment of an Elasticsearch cluster that will be the shared data store for each of those two components. It's also worth noting that we'll be exposing both of those components, API Gateway and Developer Portal, through an ingress controller so we can access them from outside the cluster. And of course, as typical in a Kubernetes deployment, each of these layers can scale horizontally, and actually we'll be seeing that a little bit later in this demo. So now, what do we need to make this work? First, we're going to need containers. SoftwareAG Government Solutions has been building enhanced security containers for many of the SoftwareAG products, including the ones at hand here, which are Web Method API Gateway and Web Methods Dev Portal. And what do I exactly mean by enhanced security containers? So first, we start from a hardened UBI-8 minimal operating system directly sourced from DoD hardened container registry called Iron Bank. And of course, we update the OS image ongoingly. Then, as soon as SoftwareAG releases a patch or a fix for one of their products, we apply that immediately on the respective container image that we build. Finally, all our images go through our FedRAMP approved process of vulnerability scanning and extensive testing prior to release into our protected registry. And speaking of registry, we have specifically provisioned a public-facing yet protected registry on GitHub for all our customers and partners. So feel free to go to the URL on the screen here and request access to the registry so you can try our containers for yourself. Then, when it comes to deployment into Kubernetes, there are many different ways to do it, but Helm Charts are one of the most common and flexible ways. So SoftwareAG Government Solution has created a Helm Chart repo where you can find Helm Charts for the different products like Web Method API Gateway, Web Method Dev Portal, and others. The idea with these Helm Charts is that not only they will allow you to deploy the containers very easily into Kubernetes, but with certain parameters that you can pass to the Helm Chart deployment, it will also allow you to configure the product correctly, passing a few parameters like passwords, licenses, and extra settings very easily as well. And because it's not always easy to get started with containers in general, with all the different containers implementations out there, different clouds, and different technologies, I've created a sample deployments projects where I outline different recipes for different container deployment types, such as containers on AWS, on Azure, on your own Docker platform, or in Kubernetes. And in the upcoming demo, I'll be following the recipe that I put together for Kubernetes. And my hope is that this project can serve as a good example for you so that you can try it for yourself in your own Kubernetes environment whenever you have time later. And finally, it's demo time. Okay, so first things first, we're going to need a Kubernetes environment. I will be using EKS on AWS as my Kubernetes environment, but you could most certainly perform any of those steps that you're going to see in your own Kubernetes environments, whether on Azure, AWS, or even local Kubernetes environments you may have. And then we're going to go to the SoftwareAG Government Solutions GitHub project and find the Web Method Container Deployments public repository that is a pinned repo at the top. And let's click into it. And as you can see here, we have multiple types of deployment, like I mentioned before, AWS, Azure, local Docker, and of course, Kubernetes. In this demo, we are concentrating on Kubernetes, so that's what we will get into. And another step down into the API management, and then a API stack clustered, because we want to deploy a realistic, scalable, clustered environment for the API management solution. So here we are in the folder. And as you can see, there are a few files and folders needed for the deployment, but I've also created a detailed step-by-step guide that I'll be going through now with some extra explanation as I go. So the first block of operations that we're going to have to do are preparation steps so our deployments work correctly. Number one, we're going to use Helm to deploy the SoftwareAG components. And I've created a simple diagrams for you to get a better understanding of how Helm works. But essentially, it is a client tool that you need to install on your laptop workstation. And using Helm commands, we're going to be able to pull the charts from a central repository, and Helm will directly talk to the API server on Kubernetes to perform the deployment for us. And here, I'll make a quick detour to our Helm Charts repo, where you'll find different Helm Charts for the products. Essentially, the ones we are interested in right now are Web Method API Gateway, as well as Web Method Dev Portal. And this is the repo we'll add into our Helm client in this first step, so we can pull the charts as needed when it's deployment time. Okay, so let's now move to step 2. And that step 2 is about Elasticsearch and our ability to deploy it very easily using the Elasticsearch operator that you can find already online on elastic.io. So again, here I created a simple diagram to illustrate what we are trying to do. Here we are not installing Elasticsearch and Kibana right away, but we're installing the operator that will help us create those components on demand at deployment time. Okay, next, we're going to create a demo namespace for all our artifacts. So that's an easy operation just to create a good grouping for our demo and keep it well organized in Kubernetes. Okay, so let's move on to the next step. And this one is pretty important since it's about pulling our containers from our protected registry. So as I mentioned earlier in this demo and as shown on this diagram, our container images are not public. They are hosted on our private GitHub registry. And as such, what it means is that you're going to need to provide an authentication token so that you can pull those images within Kubernetes. So here, that's what we're doing. We're going to add our GitHub authentication credentials into Kubernetes as a secret so that our deployment can use it to pull the images at deployment time. And finally, the last step is about adding extra configuration items for the SoftwareAG products themselves, and especially items we don't want to hard code into the deployment, right? So those are the license files as well as the administrator's passwords that we'll want to have changed automatically once the deployment is done. So let's take a look at these commands for a moment. The first set of commands is about the licenses. So we're going to add the licenses into the Kubernetes cluster. It goes without saying that you should have those license files available to you in the right place here so that the commands can find these files and add them as secrets. So that's the first thing. And the second thing is about the secrets for the application passwords that we're going to want to change automatically when the deployment happens. And so here it's simply about entering those secrets for administrator passwords and just pick whatever you want and enter them into the cluster. And now it's simply a matter of deploying the stack, meaning deploying API Gateway, Developer Portal, and Elasticsearch. We have created a simple deploy script that can do that. I think for the purpose of this demo, it may be more interesting to just do it manually. It's exactly the same, it's just more copy paste here, but that way we'll follow the deployment a little bit more closely. So let's deploy Elasticsearch first and Kibana. So we are going to launch that here, okay? Kibana and Elasticsearch are being created. As you can see in the Kubernetes pod viewer that we have those two stacks. Then let's deploy our developer portal stack. Okay, so it's using the Helm Charts that we have mentioned before, the Helm Chart repo for web method developer portal. And then finally, let's deploy our gateway stack. Same thing, Helm chart for web method API gateway. And as we can see here, we have developer portal are now running and starting. We have two API gateway pods that are also running and starting. We have two configurator pods that are waiting for gateway and portal to be ready so that they can essentially do some post-installation configuration, such as changing the passwords, adding a load balancer URL, and other configurations that you may want to apply once the deployment has been installed. And finally, the Kibana dashboards are essentially currently waiting for API Gateway to be ready so they can start properly. And here we are. The deployment is complete after around 3 minutes. and we have developer portal, 2 nodes running in a cluster, API gateway, 2 nodes. We have Kibana nodes and Elasticsearch. Everything is now running. And we also have the 2 configurator jobs that actually ran as well and configured the product properly. So let's open the UI and try to log in. Let's log in with the new password that we put as a secret in Kubernetes. And we were able to log in fine, meaning that the new password was applied correctly by our deployment. And next, we're going to check the 2 other configuration items that should have been applied, starting with the load balancer URLs for the gateway. So the deployment aware of those load balancer URLs should have applied them properly here, as we can see. And then the destination to API portal, same thing, is completely pre-configured with the right URLs, the right passwords. And if we test, it is working successfully. Now let's just try to publish some of those APIs. To save time, I've created 2 new APIs in the API gateway. I'm going to quickly activate them and publish them to the portal. And we're going to check that that works. So let's do publish. Number 1, it works. Number 2, it works. Okay, so now let's switch to portal. We go to API gallery. We see that our 2 new APIs are there. So everything is nicely working. We see the resource for the APIs, right? We see the different documentation files for that APIs. And we can even go to the try API screen and then, test one of the API. It works as well. I'm going to quickly try a get single book. And it works as well. So overall, everything is working correctly at this point. And before we finish, now I want to talk about the clustering for Gateway. So let's go to the clustering screen. And as we can see, the 2 pods that are currently deployed are well clustered together. The Gateway is detecting that. But what happens when we scale the Gateway layer to many multiple nodes? Just want to show you that the gateway will automatically detect the new nodes and add them to the cluster as well. So let's quickly go into Kubernetes itself and let's go into the deployment object for API gateway. And here for the web method API gateway, we are going to scale it to, let's say, 8 nodes. Press OK, and automatically Kubernetes is aware that I want 8 nodes now. Let's look at the pod. Now we have 8 new nodes that are being created and will essentially come up in the next few minutes. And that's it. All our nodes are now up and ready and running as detected by Kubernetes. So now let's go to the UI for API Gateway, which I'm still logged into. I will simply refresh my screen here for the clustering. And now we can see that all 8 nodes are in the API Gateway cluster, which is a really good sign. That means that any new API Gateway nodes coming up is part of the cluster and will essentially inherit all the APIs, the policies, and other configuration as the pod comes up, thanks to being part of the cluster. So that's exactly what we wanted. I think the deployment here is looking really good, really close to a production deployment with high availability, with scalability, and all in Kubernetes. And that's it for this demo. I hope you found this video useful. And I especially hope that you'll be able to try it for yourself in your own Kubernetes cluster by using the sample deployment project with the detailed steps, but also using our containers and the Helm charts that we have made available as well. Until next time, bye-bye.